There's lots of changes within inside the world as we see it in regard to sustainability. And what I want to try and do today is show you how we're using technology within a sustainable building or within modern buildings. Before we do that, I'd like to cover what is IoT, the journey. Why did SIBCA take this step to go down the IoT route? What led us to do that? So SIBCA, under the leadership of Ibrahim Lari, does every single piece of ELV that you can imagine. So every different piece of ELV, fire life safety systems, access controls, CCTV, anything that makes up the fabric of that building we deal with. But as a singular system, they almost mean nothing. So I have a BMS system, I have a fire alarm system, I have energy management systems, I have all of these different verticals. But if they're not connected together, they almost mean nothing. They're just standalone systems. So the whole concept of IoT, the Internet of Things, is we can take all of those disparate systems and we can start joining them together. And that's exactly where we started our journey. And the reason that we started our journey. So in 2018, we spotted a gap in the market. And that was for a multi-technology solution. Now, what we haven't done is we haven't taken a building management system and pushed it into the cloud. We haven't taken a fire system and pushed it into the cloud, or central battery, or whatever we're connecting to. We have created a technology base. And that allows us to deal with any technology that you could imagine that an IoT platform could consume. And we'll come on to some of those technologies shortly. Now, this also allows us to do something called cross cause and effect. Now, all of this will start to make sense when we get onto the sustainability piece. But it allows us to control one system based on something another system is doing within a building. So we can take occupancy sensors and we can start controlling lights. We can start turning on monitors. We can start diverting phone systems. We can start to control how a building is working through all of these different technologies. And that allows us to provide, allows SIBCA Connect to provide visibility through what we call a single pane of glass. It means that from my mobile telephone, from my laptop, from my desktop, from a control room, I can visualize everything that is occurring with my building, from real-time dashboards to reporting later on. So something which the civil defense team are very interested in is how do we get reports out of a fire alarm system. Previously, if you deal with older classified fire alarm systems, it's quite complicated to get reports out. Now our system is one click. So the fire alarm information comes in, the acknowledge information comes in, the acceptance and the reset all come in together, and we have a single button. So it literally allows us to click once to get the data that we need. So it just allows us to see all that information in one pane of glass. We're also seeing efficiencies with AI. I think, Dana, you touched on AI and how that's going to play out. Now, AI and machine learning for us are two absolutely critical devices that we use. Without machine learning and without artificial intelligence, it's not possible to start controlling buildings smartly. You go back to the old approach of, well, I'll just turn it off at night, or we'll just switch the lights off, we'll do this, we'll do that. But with machine learning and AI, we can start to control things in a more sophisticated way. And that allows us to get the real time, and so we'll cover real time, benefit from these systems. And all of this, as Sudi was alluding to, allows us to flatten the landscape of IoT, to make that landscape as broad as we can possibly get it. So SIBCA is taking the entire ELV spectrum and flattening it, and allowing us to pull that information in and be as flexible as we possibly can be. And through all of this, for many, 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 many years, and as Sudi alluded to earlier on this year, we went through the whole UL process. Ibrahim was very, very keen after we'd spent years developing this product. How good is that product? And as you'll see from the awards ceremony coming up in a few minutes, it's pretty good. So obviously officially born in 2023, and since then the traction now on the system has been immense. Through fire alarm systems, ELV systems, building management systems, all disparate solutions, even with buildings that don't have BMS systems we can now control. So let's cover some of the challenges that we have in making buildings sustainable. One is cost. If you said to someone, how much does an IoT platform cost? They probably would have no idea. How much is it today? How much is it tomorrow? Is my system going to be based in the cloud? Is my system going to be based on a solution for the audience here within the UAE or some of the audience in America? So we need to be very, very careful when it comes to cost, because there's no point in deploying an IoT solution and then the customer having to spend millions of dirhams in actually operating that solution with subscription packages. So that's something there's a massive pain point for us and something we have overcome by building our own solution. So we have our own private cloud solution. We don't have to pay anything to Azure or AWS or Google or anybody else. We built our own solution which allows us to control the costs, and it also allows us to fully control where we have our servers as well, which meets with the sovereignty governance within the UAE. Resistance to change. Believe it or not, businesses hate change. They absolutely hate it. If you tell someone we control your building in a different way, they'll say, no, 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 no. We control our building in the way that we want to control it, and we don't want anybody else to do it. That is something we have come up against time and time again when we've been operating or creating new control rooms for people. It's how do we change how a company works? How do we physically change? How do we educate them on how these solutions can work better for them? An awareness. If I said to you, who understands IoT? Who understands the complexities of how an IoT solution works? We find that a lot of our customers don't understand what they are, which is why, NFPA, especially with the remote monitoring on 915 and, of course, the whole UL piece, all of those awareness programs are helping with these solutions. So the fact that we're now 915 compliant, for example, is great for us because we can say on an awareness piece, SIBCA Connect is compliant with NFPA 915 for remote monitoring. And that allows the customer to get an understanding and an awareness of what we can physically do. Another challenge which we have, which will come onto the Spire program, is security concerns. There is so much going on at the moment with regards to cybersecurity. When you deploy IoT systems, what does that mean for my network? What does that mean for my servers? How do we physically secure it? Again, we're pleased to say that our solution has gone through UL and has been tested for cybersecurity, penetration testing, buffer overrun attacks, everything that you could possibly throw at the system, UL have done. In fact, I think, how long did where's Sudi gone to? I think it took three months for them to go and test everything that was security concerned with inside our package. And so we're pleased to say we still didn't have a glitch with it. How can SIBCA Connect and technology enhance sustainability? So if you have a large building management system within your building, the ways that we can improve are by controlling your HVAC systems, your smart lighting, your room occupancy, central battery solutions. Anything that the customer is going to touch, we can start controlling. And as we said earlier on, the most important thing is real-time data. Now, what a lot of customers do when they come to saving money or cost or reducing energy usage, which all goes towards ESG, that they turn things off. So my building shuts at 6 o'clock at night. I'll turn off all my AC. I'll let the building heat up through the night, and then I'll attempt to cool it in the morning when everybody comes back in. Now that, believe it or not, is not the most efficient way to run a building. We have spent months proving this. So with real-time decision-making, we can take a building and we can use machine learning and AI to find when people come into the building. What time does that building start working on particular days? What time does that person go into their specific office? So we can start to understand the trends of a building. And when we start to understand the trends of a building, we know how we can control it. So we know how best to monitor the energy and to monitor the usage. So based on consumption, based on lighting being turned on, based on the chairman being in his office at a certain time, we can start controlling everything to do with the building. And then when people leave, rather than just saying, well, at 8 o'clock we'll turn everything off, we know that a lot of people would leave at 6 o'clock, 6:30, 7 o'clock. And as they start to leave, we can start shutting those systems down. So, for example, for the last 20 minutes of the day, we don't potentially need to have the air conditioning on. So the air conditioning can be ramped down over a period of time, again, saving a vast amount of cost. Or if we don't ramp it down, we can increase the set point of the temperature because that's also a colossal way to save energy. Now, all of this for customers means one thing. That's return on investment. As long as we're controlling a building in real time, making best use of all of the machine learning that we have, the AI technologies that we're using, it offers a return on investment to the customer. And that's key because if you're trying to promote systems to a customer will not take them if they're not going to give them a benefit. You have to give a customer a benefit. You can't say, well, we're going to save all of this for you, et cetera, et cetera, et cetera. But they need to see something tangible for the solution going in. Else there's no point in paying for that particular solution. So on everything that we do, both operational and baseline costs, we try and save money. And we'll come on to an example of that shortly. So what strategies can we use to overcome these challenges? So smart sensors. Now imagine that you have a building that doesn't have any building management system in it at all. That doesn't mean to say that you cannot take advantage of a smart system, or SIBCA Connect in this case. Literally all of the devices which you see on the right-hand side here, bar the plug-in one, are all wireless devices. Because one thing that we've noticed is it's very hard to go into a building, the fabric of a building, to offer sustainability to them without disruption. There's always going to be some form of civil works, there's always going to be a disruption to a customer, which again is never a good thing. You don't want disruption to a customer. What you want to be able to do is provide smart solutions that can offer energy saving, control of your environmentals, your monitoring of energy, monitoring of water heaters, monitoring of occupancy, all of those different verticals that go to saving energy in the long run. But if you can't do that at a cost, a good cost, then it becomes prohibitive. So a lot of the solutions we're seeing in BMS world are very expensive to implement. Hence we've gone down the route of building our own mesh solution, which is Connect Mesh, which links all of these solutions together wirelessly, which allows us to very easily deploy a solution throughout a building. So we could cover a 7-story building like SIBCA's HQ within a weekend with all the technology that we have. It's very, very easy to do. With the machine learning and AI, which we now have within the SIBCA Connect IoT core, we've taken different assets. So chillers, cooling towers, pumps, every device that you could imagine runs a building, and then we've modeled it. So we know how that specific device works. So if a device takes more current, it gets too hot, it gets vibration, then we can start changing the PPM schedule for that particular device, or notify the customer when that device is potentially going to fail. So through all of our machine learning, we can give the customer warning that something's going to happen. The same that we would with a smoke detector. We would be able to notify a customer months in advance the detector is going to go into a dirty state, because we're physically monitoring how that detector is performing on a daily basis. So if that detector changes its sensitivity or it changes its dirtiness level, then they'll get a notification. That way you don't have to wait for the building to go into an alarm. It can be dealt with in real time before it gets to the alarm, before it gets to an evacuation, and before in something like a large hotel, all the lifts come down to the ground floor, because that for the customer is then a massive operational challenge. We just touched on operational savings. Most of the solutions we have sold so far are for customers that want to get operational savings. Again, it's sustainability savings. Operational savings within inside their organization. This is where you can take a customer like Aldar, for example, or DeMac or Grand Hyatt that has multiple control rooms located across a facility. And we can connect all of those devices together. So we can connect those buildings, those campuses together in a singular control room. And they can start monitoring everything from one location, which instantly saves you a vast amount of staff. For DeMac, it was driving people around a disparate area. So DeMac Hills 2, for example, if any of you know DeMac Hills 2, they have guys who physically drive around in their car to see if they have troubles within a building. So all we did is we installed a gateway to monitor those buildings for them, so now they get an alarm if there is a problem. So operational cost savings are, they don't need the additional men, they don't need the cars, they don't need the insurance, they don't have the petrol, the wear and tear. We brought the operational costs right back for them, which is an instant saving for them. They've not got to wait for the end of the year to see their cost saving. They're seeing that return on investment based on operational savings straight away. Now all of this allows us, as Sudhi was saying, is to come onto programs like Spire. So Spire for SIBCA is a program that we've been dealing with for about the last year, I think literally a year today, where we're dealing with customers within 6 different pillars of the building, being from sustainability right the way through to cyber security. And what it allows us to do is it allows us not only to offer the Spire solution to customers on how their building is running, but also having SIBCA Connect behind it to say, this is what we can physically do for your building. This would be your return on investment. This would be your operational cost savings. Now, how does this all work towards ESG? First of all, what is ESG? ESG is the buzzword of the moment, isn't it, Maha? We love ESG. So ESG is basically environmental, to start with. So the idea that you have to reduce your carbon footprint. Now, everybody's trying to get to a carbon neutral status at the moment. But with the advent of EVs and everything, it's very, very hard to reduce your carbon footprint. So what we're doing is we're attempting to work with customers to show them how we can reduce energy usage within a building. Now again, like a BMS system, we don't just control chillers. Within SIBCA Connect, we have the ability to control the actual FCU controllers of that specific room. So we can start controlling things at room level rather than at a holistic level. So it allows us to get massive, massive energy savings. I've got a slide for that shortly. Social impact. As we said, occupancy, well-being. We can take a disparate set of buildings and we can start to push those disparate buildings together to allow a customer to better understand and better control those buildings. That then allows a lot of the guys to work in a safe environment. It allows a whole community impact because you're able to see what's going on within the buildings from a single location rather than spread out where your teams don't necessarily talk together. And then governance. So everything which we do within SIBCA Connect is fully reported on. So everything we're doing allows us to get reports out, best practice reports, and how the system and the buildings are performing. And of course, with the advent of COP28, this obviously allows us to collate all of that data and address a lot of the ESG concerns. So this is a real-world implementation. Now, this is actual ADDC data of energy usage that we have. So in April of this year, we started working with a customer, and we set a baseline. Now, one thing to note here, if you're using machine learning and AI doesn't just work overnight. It's something that you need to build a profile for. So you can't just turn on your machine learning and AI and just expect it to save the world. It unfortunately doesn't work like that. So we have an entire month of just the system gathering data. Now that could be people's movements, that could be doors opening and closing from the security system, that could be window usage, that could be ACs being turned on, this could be lights being turned on. We need to capture absolutely everything to do with the building. And then in May, we entered some best practice. So we have some very, very clever people working for us. I mean, very, very clever people. Make me look very stupid. But we have some best practice machine learning. So we know how a lot of these solutions work. And we start to implement that data within SIBCA Connect, and we have the control. So SIBCA Connect starts to control those devices in what we believe is a best practice. But we're still learning. The system is still there, it's still learning, and it's limiting its AI. It's still thinking, how can I make it better? And then in June, we then let the system run itself. Even after all of our boffins have thought, yes, we can do a very, very good job here, and we reduce the energy over 50%. The system was able to reduce the baseline energy by 64% in this specific case. And that's an equivalent cost save, or CO2e, of 700 kilograms. And that's in a small environment where we're only dealing with something up at 4,000 kilowatt hours. So even within the space of 3 months, we're able to provide that sort of saving for a customer, not just cost saving, but also towards ESG as well, and how we would physically promote the environment, in this case, save and work towards a carbon neutral thing. Okay. Thank you.